أولى ثانوي، فرصة جديدة وحلم جديد وهنعديها بالتأكيد، وهنعديها بالتأكيد. أولى ثانوي.
أهلا بكم طلبات الصف الأول الثانوي على قناة مدرستنا 3 تحت إشراف وزارة التربية والتعليم. Today we will continue what we studied or explained in the prior or previous session. We will continue the studying the motion of the object, and we will take a new concept that related to the motion of the object. Let's see. As we said before, we study just only the linear motion of object, and the first thing that we have some objective of this lesson, which is define a new concept which is called acceleration and compare between its type. As we taken before, we have many types of velocity, we have many types of acceleration too. We will deduce the equation of motion at a uniform acceleration. How can we use or find or explain the motion of object with uniform acceleration? And then we represent or explain to the graph that represents the relation between the acceleration of the linear motion that we have. And we have, at the end of our session, a new concept which is called a free fall, the meaning of free fall. Let's start. What is the meaning of acceleration at the beginning? Of course, it is too difficult to move all the time or from the beginning of the motion to the end of motion with the same velocity or with a constant velocity, because we have variable conditions around us during the motion. So, sometimes we need to exceed or increase the velocity, and sometimes to decrease the velocity or keep it constant. So, the rate of a change of the velocity of motion, this is called acceleration. هي ده تعريف الاكسلريشن. هو احنا طول الوقت احنا ما بنقدرش طبعا، it's difficult but it's not impossible ان احنا نفضل ماشيين او في خلال الحركه بتاعتنا من مكان لمكان ان السرعه بتاعتنا تفضل ثابته. مش بسببنا، احنا ممكن بتحصل داخلين على مطب هنهدي السرعه شويه، في اشاره هنقف فهنضطر نهدي، الطريق واسع مفتوح قدامنا هنسرع شويه. So all the time we have a change in our velocity. The rate of a change in this velocity is called acceleration. So acceleration, it's denoted by the letter A. هي الرمز بتاعها A, which is equal delta V over delta T, which means a change of velocity over the time of a change. And the measuring unit of acceleration is meter per second square or kilometer per hour square. Acceleration, of course, it's a vector too. Just like as we said in velocity, it's a rate of a change of velocity. Velocity, it's a vector. So consequently, acceleration, it's a vector too, which means it's had a magnitude too and a direction. And this is as we defined always. As we said, the velocity, it has magnitude and direction. So the change in any of them by time makes the object gain acceleration or leads to the presence of acceleration. يعني ايه الكلام ده؟ يعني الاكسلريشن مش المقصود بيها speed up او ان انا ازود سرعتي او ان انا اقلل سرعتي بس. لا، انا ممكن اكون بتحرك بسرعه ثابته موجوده عندي بس بعمل change في الدايركشن. So we have here one of the two factors of the vector is changed, which means it leads to the presence of acceleration. As you see, just like in the car, it moves in a straight line, and when it changes its direction to the left or to the right, which means it changes its direction, we call in this case the car moves with acceleration or it has acceleration. Just two photos to explain what we said before. The car هنا accelerating when it changes its direction. Okay, a change in both direction and the magnitude of the car. طبعا اي حد بياخد كيرف او بياخد منحنى بيهدي من سرعته شويه، فبالتالي هنا هو عمل change في magnitude of the velocity and in the direction too, which means the car moves or gain acceleration. In the second shape, or in the second form that we have over here, if we find here over here, we have a moving object with a constant velocity, 30 mile per hour. Then it turns with the same magnitude or the same speed. We call it 30 mile per hour. Then it changes another time the direction of the motion. So the magnitude of the velocity, it's a constant all the time, but it changes the direction. So we said here the object moves with acceleration because we have a change in the direction of the motion. But we can say it's a constant speed, not a constant velocity, because the magnitude just only is the constant. So change in direction of velocity only, which makes the object or the car moves with acceleration. In which case do you think acceleration is involved? If we have a plane over here which moves with a constant speed with 1000 kilometers per hour, and this car moves with 80 kilometers per hour, which one of them do you think, in your opinion, has acceleration? The car or the plane? Which one of them? It's a constant speed, here constant speed, and both of them moves of straight line. No acceleration. None of them has any acceleration. Why? Because it's written here, it's a constant speed. There is no change in the magnitude in the velocity. Plus, they moves in the same straight line, which means there is no change in direction. So they move with velocity in a constant magnitude and with the same direction or constant direction. There is no change in velocity, which means zero or no acceleration. This is a simple example just for the application of the law of acceleration. If you have here a car and this drag increases its velocity from zero, we have الكار هنا هتبتدي السباق بتاعها. طبعا of course it's static. So the initial or the first initial velocity equals zero, and the velocity increases from 0 to 60 meters per hour in 3 seconds. Find the acceleration. عاوزين الاكسلريشن. كان object ساكت، العربيه كانت ثابته، بعد كده غيرت الفيلوسيتي بتاعتها في 3 ثواني خلال 3 سكند بقت 60 متر بير سكند. عايزين الاكسلريشن. طيب الاكسلريشن بتيكوال ال v final minus ال v initial اللي هي ال v2 or minus ال v1. In some books you can find it they denote the velocity v2 minus v1 or vf minus vi اللي هي ال final minus ال initial over the total time of change. So ال final velocity it's a 60 and it started from rest, which means v1 equals 0 over the time of change يبقى 60 over 3, which is equal 20 meter per second square. This is the acceleration of the object. Graphical representation of acceleration as we خلاص I think ان احنا بقى خلاص بقينا عارفين لما بنيجي نعمل الجراف لاي physical quantity عندي بنشوف فين الفاكتورز اللي affect الفيزيكال quantity عندي، ونشوف هنعمل مين على الواي اكسس ومين على الاكس اكسس، ونشوف شكل الجراف and from the type of graph we can find the type of this physical quantity, just like velocity and speed as we taken before. So when we represent graphically the acceleration, we need two physical quantities, which is r, of course, very good, velocity and time, because acceleration it's a rate of change in velocity of the object. So when we trace or draw the graph that represent the velocity of the object on the y-axis and the time on the x-axis, when we get a straight line just like this, what represents the slope of this line? السلوب بقى هنا خلاص بقى احنا اتعودنا خلاص خدنا حاجات كتير واثينك ان احنا الجرافينج سكيلز بتاعتنا it increases دلوقتي. طيب we are velocity by time والسلوب هنا represent the change of the physical quantity on the y-axis over the physical quantity on the x-axis, which means delta v over delta t, which is acceleration. So when we draw the graph between velocity with time, the slope of the line is represent the acceleration of the motion of this object. And if we get a straight line just like this, which means very good, it's a constant acceleration. إن acceleration اللي بيتحرك بيها الجسم هي acceleration ثابتة. ليه؟ Because this is a straight line and the slope of the straight line it's always a constant value. But it's not always a constant acceleration. Just like velocity, it's not always constant. We have some condition that makes us change the velocity. Of course, we have many types of acceleration, just like as we will see together. The types of acceleration we have here: positive acceleration and negative acceleration, and sometimes we have zero acceleration or no acceleration. How can we find it graphically or from the graph? A positive acceleration, what is the meaning of positive acceleration? طيب احنا مبدئيا كده قلنا الاكسلريشن عباره عن الريت اوف تشينج اوف velocity. rate يعني divided by time، يعني change in velocity by the change of time. طب to get a positive acceleration يبقى لازم يكون اللي change في velocity يكون positive. طب امتى يكون اللي change في velocity يكون positive؟ لما يحصل ايه؟ اما يكون increasing في value في الماجنتيود بتاع velocity نفسها، تمام؟ ويكون الاوبجكت نفسه moves in the same direction of velocity. يعني even لو انا بزود الفيلوسيتي بتاعتي ويكون الانكريزنج برضه still in the same direction of motion. يعني مش الاوبجكت مثلا بزود الفيلوسيتي بتاعتي ورحت مغيره الاتجاه بتاعي، لا، انا still in the same direction of motion by increasing the value or the magnitude of the object الموجود عندي. Just like the flow of the apple from the tree to the soil or on the floor. This is a positive acceleration. Why? Because this is the direction of the normal motion. هو الطبيعي والبديهي ان لو عندي حاجه متعلقه المفروض لو ما فيش اي effects موجوده حواليها هتتحرك في اتجاه مين؟ الجرافيتيشنال فورس الموجوده عندي اللي هي it's gonna to on the floor. Negative acceleration. Negative acceleration يبقى المفروض عشان يكون عندي negative acceleration لازم يكون اللي change في الفيلوسيتي الموجود عندي يكون الفاليو بتاعته تكون negative. طب امتى بقى الفاليو بتاعتي تكون negative؟ When the velocity of moving object decrease with time uniformly. لو بيحصل عندي decreasing في الفيلوسيتي which means ان ال V final أو ال V2 it's less than the V1. فبالتالي لما باجي عندي اعمل V2 minus V1 هتدي negative number. فبالتالي المفروض عندي هنا هيكون عندي الفاليو بتاعت الاكسلريشن is negative. تمام. In this case we say that the object or the car or whatever being a moving object it moves with negative acceleration. When we get to zero acceleration امتى بقى اللي يكون عندنا zero acceleration؟ When there is no change in velocity. ما عنديش اي تغيير في الفيلوسيتي بتاعتي لا في الماجنتيود بتاعها ولا في الدايركشن بتاعها. Let's see on how can we explain the three types of acceleration in the same graph. If we represent, as you see, the velocity on the y-axis and the time on the x-axis. In this part of the graph, we find this represents a straight line and direction is upward. And the slope here is represent the acceleration. It's a constant positive acceleration. تمام؟ طيب. In this part of the graph, this is a straight line. As you see, it's parallel to the x-axis, which means the slope equal 0, as we said before. When the slope equals 0, which means the delta v, or the change in velocity, equals 0. Which means in the object هنا moves with a constant velocity. ما عندوش أي change في الفيلوسيتي بتاعته، فعندي هنا acceleration equals 0. In this part of the graph, you find it's a negative acceleration because the slope of this line is in negative, and the slope here present the acceleration of the motion of the object. If you have this, this is just a fast or a little example. We have here a car passes from point A to the point B, okay, with velocity of 10 meter per second. It has a steady or constant acceleration which is equal 4 meter per second square. What is the velocity when it passes point B? يعني ايه الكلام ده؟ دلوقتي انا عندي الكار دي بتبدا الموشن بتاعتها بفيلوسيتي 10 meter per second and it has acceleration which is equal 4 meter per second square. What is the velocity when it passes to point? عايز بقى هنا الفاينل velocity بتاعتها لما توصل للبوينت B. تمام؟ طيب دي it's a direct application or direct applying لمين؟ للاكسلريشن. انا عندي الديفينيشن بتاع الاكسلريشن equal v final minus v initial over التايم. we need ال v final مش عايزين ال v final which is equal. طب ال v final هنا equal ايه؟ from the change هنا نجيب ال v final ازاي؟ يبقى عندي هنا ال v final equal acceleration times time a times t over 1. اوكي في الترم ده بعد كده هنعمل فيه ايه؟ بلس مين؟ ال v initial او ال v1 الموجوده عندي. طب لما نعمل بقى substitution لكل الفاليوز الموجوده عندي، الاكسلريشن which is equal 4 meter per second square، التايم equal 6. اوكي this is term plus مين؟ ال v initial الموجوده عندي اللي هي كانت بكام؟ ب 10 meter per second plus 10. 4 times 6 equal 24. 24 plus 10 equal 30. 34 meter per second. And this is the final velocity. يعني when the object gets at this point, he will get its velocity will be 34 meter per second. In this case, this is another example which is collect between all types of acceleration in the same graph. As you see, all of these numbers or the relations between the velocity and the time, which means هو عايز يبقى من الجراف ده represent, calculate the acceleration for each of the 4 sections of the graph. We have here 4 sections and we need to know or the magnitude of the acceleration at each section. The first section, which means the slope of this line. The slope which is equal, this is the change of the y-axis, which is 40 minus 0 over the change or the time of change, which is from 0 to 10. يبقى 40 minus 0 over 10, which means 4 meter per second square. Okay. At the second section, this is, of course, there is no calculation. As we said, when we have a straight line parallel to the x-axis, which means slope equals 0, which means acceleration at this section equals 0. And here, with the same manner or with the same method, we will find the change in velocity at this section, which is equal 20 minus 0 over 10, which is equal to meter per second square. And in the last section or the fourth section, from acceleration, which is equal 0 minus 60, which this is the change of the velocity. 0, yes, of course, because we take the final magnitude or the final value. What is the final value in this section? This is here, 0. As you see, at this point, the value of the velocity equal 0. There is no reading on the y-axis. But final velocity equals 60, and the initial 0. Sorry, the final equals 0. The initial here is starting from the 60 over the total time, which is 20 seconds. So the acceleration here equal minus 3 meter per second square. And the last concept, which is the free fall. Free fall and the meaning of the acceleration of free fall. If we have two objects, a big object and small or light object, and we drop them from the same height. معايا جسمين، واحد تقيل شوية وواحد خفيف، والاتنين موجودين على السيم هايت على نفس الارتفاع، وسبت الاتنين. منطقيا كده او logically مين اللي هيوصل للارض الاول؟ as this example مثلا لو عندي دي piece of paper مثلا وعندي هنا building block وسبت الاتنين يقعوا كده على الارض، مين هيوصل الاول؟ طبعا كله هيقول مين؟ البلوك، لان البلوك دي اصلا المفروض ان هي تقيله فهي هتوصل الاول. هو المفروض scientifically الاتنين يوصلوا مع بعض في نفس الوقت. ليه الاتنين يوصلوا مع بعض في نفس الوقت؟ لان الاتنين بيحصل لهم acceleration with the same magnitude. الاتنين بيحصل لهم acceleration change في الفيلوسيتي بتاعتهم بنفس المقدار. طب فين الاكسلريشن دي؟ هو مين اللي جاب الاكسلريشن دي؟ في حاجه اسمها الجرافيتيشنال اكسلريشن اللي هي عجله الجاذبيه الارضيه اللي هي الجي اللي احنا كنا بناخدها واحنا صغيرين. فالمفروض لو انا ما عنديش هواء خالص there is no air resistance، المفروض التو اوبجكت بيحصلوا فين؟ بيوصلوا they will fall with the same download acceleration أو downward acceleration. They will reach to the soil at the same time. بس عشان أنا المفروض في بيبقى عندي particle of earth فدي بتعمل لي some resistance للموشن بتاعتي. فبتلاقي لو هما الاتنين بيتحركوا في الهواء كده فهتلاقي الجسم الكبير هو اللي وصل الأول. تمام؟ فالاكسلريشن اوف موشن فور these two objects which is called acceleration of free fall اللي هي عجلة السقوط الحر. يعني الاوبجكت بيتحرك تحت تأثير حاجة واحدة بس اللي هي الجرافيتيشنال فورس اوف ذا ايرث اللي هي عجلة الجذب اللي هي قوة جذب الأرض للأوبجكت الموجود عندي. And now my dear student, let's go to the light board just to have a summarize and see what we have taken today. اتكلمنا النهارده عن concept جديد which is called acceleration. واتكلمنا ان احنا قلنا الاكسلريشن symbol بتاعها which is A وهي عبارة عن rate of change of velocity of this object. And as we said before, velocity it's a vector which means it has magnitude and direction. Which means just to find acceleration it happens أي object during الموشن بتاعته لو في حصل change في أي حاجة من الاتنين. Magnitude of the velocity or the direction of the velocity we said that this object gains acceleration. Just as we said before, or as we have taken, we have many times of acceleration, which is just like if we represent relation between the velocity on the y-axis, will time on the x-axis per second. If we get a straight line, the slope of this line will represent an acceleration of motion. If we get a straight line just like this, the slope is a constant value, which means the object has a constant or moves with constant acceleration. If we get, we have many types of acceleration, and if we summarize and represent all the types of acceleration on the same graph, we will get this or this or this. In this part of the graph, the object moves with a positive acceleration, which means the velocity of the motion increase by time with a regular change. And in this part of the curve, there is no change in the velocity of the motion of the object, which means the delta V over delta T, which is equal 0, which means there is no change in the velocity, we have no acceleration. In this part, we get a negative acceleration, which means the object decrease its motion, the velocity of the motion by the flow of the time till he stopped over here, and at this point when the object stops, which means the velocity of the motion equal 0, which means the object is stopped of the motion. And we stopped over there. This is what we talked about the acceleration and its type, and of course the measuring unit of acceleration it's meter per second square, and because of course it's delta V over delta T. This is what we have taken. This is all for today. Thank you for watching. Thanks for being with me. I hope it's useful and interesting for today. Thank you. See you next time, inshallah. My dear student, this is all for our session for today. Thank you for being with us. I wish you a happy day and have a nice day. Thank you. See you next time, inshallah.
أولى ثانوي، فرصة جديدة وحلم جديد وهنعديها بالتأكيد، وهنعديها بالتأكيد.